Today's notes are going to be on 5.7, the Pythagorean theorem. The Pythagorean theorem is an important theorem that's used to find a missing side in a right triangle. Now, a right triangle is comprised of a triangle that has one right angle. Now, in a right triangle, we can label the sides of a right triangle as having legs. Two sides have legs, and one side is called the hypotenuse. The hypotenuse in a right triangle is the longest side in a right triangle. It is always located opposite the right angle. So again, the hypotenuse is the longest side in a right triangle. It is always located opposite the right angle in the triangle. Here's the right angle. There's the hypotenuse, opposite side from that angle. The Pythagorean theorem is used to find a missing side in a right triangle. The Pythagorean theorem is known as a squared plus b squared equals c squared. Now the key is locating the hypotenuse. The hypotenuse is represented by c. So again, C represents the hypotenuse. The other two sides, A and B, represents the legs. It doesn't matter which side you designate as A or as B, but C matters. You must correctly identify the hypotenuse to make it C. Okay, so let's move on to example 1. In example 1, we need to solve for x in this problem and then in y in the second triangle. So in the first one, I'm going to set up my equation, a squared plus b squared equals c squared. And I want to correctly identify my hypotenuse. Well, my hypotenuse is always opposite the right angle. Here's my right angle. So the side opposite it is the side that's labeled as x. So that's my C. And the other two sides, it doesn't matter which one I make A or B. So I'll make 4A and B the 8. And then I'm going to put it into my equation, a squared plus b squared equals c squared. So I have 4 squared plus 8 squared equals x squared. Now remember, squaring a number means to multiply it by itself. So 4 squared means 4 times 4, which is 16. 8 squared is 8 times 8, which is 64. After you squared those numbers, you need to add them together. 16 plus 64 is 80. Now, to end this, I need to take the square root of x and 80. So it would be square root of 80 equals x. If I can break it down, I want to. So 80 numbers that multiply to get 80 could be 8 and 10. 8 numbers that multiply to get 8 could be 4 and 2. 4 breaks down to 2 and 2. So here's one pair. 10 can still be broken down to 5 and 2. Another pair of 2's, and what remained is 5. So to simplify this, I'm going to take one pair of 2, put it outside, take another pair of the 2's, take it outside, I'm going to multiply them together. What remained will go underneath the radical, which was 5. 2 times 2 is 4, so it's 4 radical 5. I can check my work by doing 4 squared. 4 squared is 16. Multiply that by 5. 16 times 5 gives me 80, and I know I did it right. That was the first triangle. Now in the second triangle, we're going to solve for y. So again, I need to first label my sides. The key again is labeling the hypotenuse. The hypotenuse is the side that's always opposite the right angle. Here's my right angle. Here's my hypotenuse. So this is C. The other two sides don't matter which one is A or B. So I'll make this A and this B. And then I'll write my equation. A squared plus B squared equals C squared. And that means y squared plus 12 squared equals 6 radical 5 squared. So I have y squared plus 12 squared is 12 times 12, which is 144. Now 6 radical 5 squared, that's a tough number to square it. So what this means is to take 6 radical 5 and multiply it by 6 radical 5. So over here on the side, I'm going to do that. 6 radical 5 times 6 radical 5. When you multiply numbers like this, you want to multiply the numbers on the outside together. So I'm going to take 6 times 6, which is 36. And I need to multiply the numbers inside together. Radical 5 times radical 5. Radical 5 times radical 5 is radical 25. And the square root of 25 is just 5 without the radical. So then it's 36 times 5 now. Now 36 times 5, well, that will give me 180. So that's what I'll replace over here. That's what 6 radical 5 squared becomes 180. Okay, and now what I want to do to solve this is I want to get y squared by itself. So I'm going to take 144 and subtract it on both sides. So I'll minus 144. So y squared equals 180 minus 144 is 36. And then to solve this, I'll take the square root of both sides. And the square root of 36 is 6. And that's the first page. Any questions on that? Okay, so let's flip over to page 2. In page 2, okay, in example 2 here, you need to find the height of the triangle. Now I'm going to give you some hints before you're going to try this yourself. The right triangle is right here. Okay. Now that you're told this whole distance here is 10. Now these slash marks mean these two sides here are equal. So if this whole thing is 10, that means each of these have to be 5 and 5. So now you have a right triangle here. You're only missing one side. Go ahead and find that side right now yourself. Okay, so now that you've had some time to solve that problem, let's do it together. So first I'm going to do a squared plus b squared equals c squared. Label my sides here. This is my c, because it's opposite the right angle. The other two sides don't matter. I'll make this my a and this my b. And substituting in, I can do h squared plus 5 squared equals 10 squared. So I have h squared plus 25 equals 100. I'll then subtract 25 on both sides, which gives me h squared equals 75. And then lastly, I need to take the square root of 75, and 75 can be broken down into 3 times 25, and 25 is a pair of 5s, with 3 remaining, so 1 5 comes out. Under the radical is the number 3. And there's my answer. I'll check my work. 5 squared is 25. 25 times 3, 75. Now I know I simplified it correctly. Okay, in example 3, we've done some of these problems before. Remember back in Unit 1, you had to find the distance from A to B here in the coordinate plane, and I showed you how to use the Pythagorean theorem in that problem. You do that by creating a right triangle. So in essence, you can draw a straight line down here, straight line across, and down like that. And then count your sides here. So this is 1, 2, 3, 4. Count here, 1, 2, 3, 4, 5, 6. And then here, that's what we're trying to find the length of. We don't know it, so that's our x. And then this is where your right angle would be formed, and you have a right triangle, and now we can use the Pythagorean theorem. So I would do a squared plus b squared equals c squared. Now again, you want to label your a and b in this problem, and c. And c will be the hypotenuse here, opposite the right angle, so this is my c. Either one could be a or b. So I'll do 4 squared plus 6 squared equals x squared. Now 4 squared is 4 times 4, 16. 6 squared is 6 times 6, 36 equals x squared. Now 16 plus 36 is 52. And lastly, I would solve this by taking the square root of 52. Now 52 can be broken down into 2 times 26. 26 is 2 times 13. I got a pair of 2's, 13 remains, so I put 13 underneath, put 1 2 outside, and there's my answer. Any questions on those two examples there? Now, the converse just means the reverse. Okay, so if The original Pythagorean theorem says, if you have a right triangle, then a squared plus b squared equals c squared. Well, what if I wanted to prove that a triangle is indeed a right triangle? I can use the Pythagorean theorem to prove that. So, if a triangle is a right triangle, then a squared plus b squared will equal c squared. Now, if it's not a right triangle, then it won't work. A squared plus b squared will not equal c squared. So we want to see if that will indeed work. If it works, we know it's a right triangle. If it doesn't work, not a right triangle. So, down here in our examples, we have this right triangle here. Now, when you're going to label your sides, okay, you got to first make sure you're labeling your C. What would, in essence, be the C if this is a right triangle? And it has to be, remember, the hypotenuse has to be the longest side. So 13 must be the C in this case. A and B, remember, it doesn't matter, so we'll just leave this A and this B, and we're going to do the Pythagorean theorem. If we get a true workable statement, it's a right triangle. If we don't, it's not. So, C was 13 in this case, and we have 10 squared plus 7 squared equals 13 squared. So 10 squared, that's 10 times 10, which is 100. 7 squared, 7 times 7, 49. And that will equal 13 squared, which is 169. Well, 100 plus 49 is 149. And 149 is not equal to 169. Okay, so since it's not equal, that means this triangle is not a right triangle. Okay, so this triangle is not a right triangle. Okay, so in this example here, we want to identify again the longest side. So the longest side in this one is actually 8. Now the reason I know that it is 8 and not 4 radical 3 is because I'm going to do some mathematical reasoning here. What if this was instead 4 radical 4? Well, I know that the square root of 4 is 2. So 4 times 2 will give me 8. But since, and that's the same as 8 here, which will make these sides the same. But since this number is radical 3 and not radical 4, less than this side must be less than 8, making it smaller than this side. That's why this side, 8, is the longest side. So I'll put this as my C, and either one could be A and B here. And we're going to do A squared plus B squared equals C squared. So I can do 4 squared plus 4 radical 3 squared equals 8 squared. Now remember, if I do this and I get a true statement, it's a right triangle. If I do this and it's not a true statement, then I know it's not a right triangle. So 4 squared, that is 16. 4 radical 3 squared, again I'm going to go off to the side to do this because again this is still type a little challenging here. So 4 radical 3 squared is 4 radical 3 times 4 radical 3. You multiply the numbers on the outside together, 4 times 4, which is 16, and the radicals inside together. Radical 3 times radical 3 is radical 9, and the square root of 9 is just 3. So we have 16 times 3, which is 48. And 8 squared is 64. 8 times 8 is 64. We add 16 and 48 together. That is 64. So we got a true statement here. 64 does indeed equal 64. So this is a right triangle. And that concludes today's lesson.